So let's start with another interesting and important topic, that is chemical bonding. So let me introduce you to this concept that what exactly the chemical bonding is. See, you all know that we all live with our families, right? So in family, we have different family members. There is a linkage that holds us together, right? And we form one family. What is that linkage? Or you can say, what is that bond that holds different family members together in a family? That is a bond of love, right? So likewise, here we are going to study a bond that is a chemical bond which holds the atoms together in a molecule. So you can say that it is also a kind of bond of love that holds the atoms together in a molecule. Got it? So if somebody asks you about chemical bonding, what are you going to answer? So you're going to say like this: chemical bonding is a linkage that holds the atoms together in a molecule. Got it? Now the question is, what is the prime cause behind chemical bonding? Why is it necessary? See, we all know that like in universe, everything needs to attain stability, right? Like that, the atoms also need to attain stability. How can they attain stability? They can attain stability by attaining stable electronic configuration, right? And how can they attain that? They can attain stable electronic configuration by combining with the other atoms. When they combine with other atoms, either they lose electron or they gain electrons or they mutually share electrons, and in doing so they attain stable electronic configuration, or you can say the inert gas configuration. Now how they lose and gain or share and how they attain stability, we are going to discuss with the examples. But before we proceed, you should know that we have two types of chemical bond. We have two types of chemical bond. One is the ionic bond and the second is covalent bond. So let's start with the ionic bond first. So ionic bond, the other name for this bond is the electrovalent bond. We can also call the ionic bond as electrovalent bond. Now how is this bond formed? It is formed specifically between metal and a non-metal. It is formed between, write it down, metal and a non-metal, right? And in this bond formation, the transfer of electrons take place. That is, one atom will donate electron and the another atom will accept electron. And after losing and after accepting, they acquire the noble gas configuration, right? So let's take an example in order to understand it in a better way. So let's take one example, one metal and one non-metal, and let's form a bond between them. So let's say I have one metal, that is sodium. We know that the symbol for sodium is Na, right? And the non-metal which I took is chlorine, that is the symbol Cl, right? Let's write their atomic numbers. We know that the atomic number for sodium is 11 and for chlorine it is 17, right? And accordingly we can write the electronic configuration. So for sodium it is 281 and for chlorine it is 287. Now in case of sodium, you can see that the configuration is 281. Do you think that it has noble gas configuration, or do you think that this sodium is stable? No, it is not stable because the octet isn't complete, right? And how it can complete the octet? It can complete the octet by giving one electron, right? So that is the reason we start with the metal first. In the formation of ionic bond, we have Na, right? Its valence electron is 1, which it will give. So I will show this electron as a dot, right? So this dot means valence electrons of sodium, which is 1. It will donate 1 electron, that is minus 1 electron, and after losing it is forming Na positive, that is the sodium electropositive ion or sodium ion, right? Now this 1 electron will be taken up by the chlorine, because chlorine possesses electronic configuration as 287. It needs 1 electron in order to attain noble gas configuration. So what it will do, it will accept this 1 electron, that is Cl, and we will show the Cl with 7 electrons around it, and we will arrange the electrons in the form of sets. You can see that we have Cl 2, 2, 2, that is 6, and 1 is the another electron. That is total we have 7 electrons. It will gain 1 electron plus 1 electron and it will form Cl negative. Right, so sodium is stable because Na positive, like the configuration for it is 2, 8 now. The octet is complete, and for Cl negative, again the octet is complete because the configuration is 2, 8, 8. Right, so overall reaction becomes Na with 1 valence electron, Cl with 7 valence electron forms Na positive Cl negative, and we will crisscross the valencies, their superscripts, and we will get the desired compound, that is the ionic compound, which is NaCl. Got it? That how the ionic bond is formed. Let's take one more example and form another ionic compound. Magnesium and oxygen this time. Got it? So magnesium is metal, Mg, atomic number is 12, configuration is 282. Got it? So for oxygen, atomic number is 8, configuration is 2 and 6, 2, 6. Now we know that this is metal because it has 2 valence electron, and it is non-metal because it has 6 valence electron. And the bond formed between metal and non-metal is always due to transfer of electrons. Metal will lose and non-metal will accept. That means it is ionic bond. So let's form it. We are denoting it with the help of dots, right? So it will lose 2 electrons, minus 2 electrons, forming Mg2 positive. Got it? Now we have oxygen. We know that oxygen possesses 6 valence electrons. We are distributing in the form of sets, 2, 2 and 2, that is 6, plus 2 electrons because it needs 2 electrons to complete its octet, right? And it will form O2 negative. Now the overall reaction which is involved in the bond formation is Mg with 2 valence electron plus oxygen with 6 valence electrons, and it forms Mg2 positive and O2 negative. We will crisscross the valencies, their superscripts. We get Mg2O2, 2 and 2 cancel, and the formula becomes MgO, that is magnesium oxide. So this is how you need to show the bond formation in case of ionic bond. Got it? So let's move on to the another type of bond, that is covalent bond. So covalent bond is a bond, let's define it first. It is a formed due to mutual sharing of electrons. It is a bond which is formed due to mutual sharing of electrons, right? It is always formed between non-metal and a non-metal. Like if you get 2 elements, one metal and one non-metal, the bond formed will always be an ionic bond because one is donor and other is the acceptor of the electron. But if we get 2 non-metals, then the bond formed between them is going to be covalent bond because both are acceptors. They cannot donate electrons, but both of them at the same time need electron in order to attain noble gas configuration. So how will they attain? They will mutually share electrons. Got it? So covalent bond, the first thing is it is formed by mutual sharing of electrons. Second is it is formed between non-metal and a non-metal. Got it? We have basically 3 types of covalent bonds. One is single covalent bond, second is double covalent bond, and the third is triple covalent bond. This single, double and triple, don't get confused with the names. It just depends upon the number of electron pairs. Like if 2 atoms are combining and both of them are contributing 1 electron each, they form the 1 electron pair and the bond formed is single covalent bond. And if they contribute 2 electron each, they will form the double covalent bond because there will be 2 electron pairs. And if they contribute 3 electrons each like this, right, and they are forming a bond due to mutual sharing of 3 electrons, so there will be 3 electron pairs and the bond formed will be triple covalent bond. Got it? So let's form the single covalent bond first. So single covalent bond is that, first we need to define it, right? So single covalent bond is a bond which is formed when there is one shared pair, one shared electron pair. Got it? So let's take an example of the hydrogen. Let's see that how hydrogen molecule is formed. We know that hydrogen molecule is something H2. Got it? H2 is an hydrogen molecule, and as you can see its formula, and it is clear from the formula that hydrogen molecule is being formed when 2 hydrogen atoms combine with each other, right? So that means we have one hydrogen and we have one hydrogen. atomic numbers, we know hydrogen atomic number is 1. So 1 and 1. Now if we write the electronic configuration, it is going to remain same. That is 1 and 1. We know that in case of hydrogen, we obey the duplet rule. That is tendency to attain 2 electrons in its first shell. Got it? So that means they need 1 electron to attain stability. So what they will do is, when 2 hydrogen will come closer, we can we have to denote the electron, number of electron which they need to share. We have to denote those electrons and write in the middle. So we have this 1 hydrogen, and this 1 dot is the 1 electron which it is going to contribute in the shared pair. Similarly, this hydrogen also possesses 1 electron which it is going to contribute. So both of them come closer. This hydrogen has its 1 electron and it will share this 1 electron of other hydrogen atom. In a similar manner, this hydrogen has its 1 electron and it is going to share the 1 electron of other hydrogen atom. So that means both are contributing 1 electron each, right? So that means it has 1 shared pair, and 1 shared pair means single covalent bond. So this is how mutual sharing takes place. Now let's move on to double covalent bond. So first we need to define it. Double covalent bond means a bond in which 2 shared pair of electrons are present. Let's see how the bond is present in oxygen molecule. We know oxygen molecule is O2. Got it? That means 2 atoms of oxygen combine to form 1 oxygen molecule. Let's separate them and just see that how they form bond. So we have 1 oxygen, we have another oxygen. Atomic number for both is 8. 8 here, 8 here. And if we write electronic configuration, so for both it is 2, 6, and also for this it is 2, 6. So that means both of them need 2 electrons in order to attain stability. Got it? So that means when we will show the bond formation between these oxygen atoms, we have to denote the valence electrons, and there is a particular way of denoting the valence electrons. We will denote in the form of sets. So we have 1 oxygen, 2 electrons here, 2 electrons here, and 2 in the middle, because 2 electrons it is going to contribute. So whatever it is going to contribute, we have to write in the middle. It should be middle facing. Got it? For the other oxygen, again it has to be same. Now this oxygen possesses 6 electrons and 2 it will share from the other oxygen, and somehow it has attained 8 electrons and it is balanced. Right? Balanced means it has attained stability. Now for the other oxygen, again it has 6 of its own and 2 it is sharing from other oxygen, and this is how you can make the electron cloud in order to show that it is sharing the 2 electrons of other oxygen atom. So in this case, both are contributing 2 electrons, and this is how the bond is formed. So there are 2 shared pairs, that means double covalent bond is formed. Got it? So likewise, we form the triple covalent bond. So triple covalent bond is a bond which has 3 shared pair of electrons. So let's see that how nitrogen molecule is formed. We know that nitrogen molecule is N2. Got it? N2 means 2 nitrogen atoms are present. So we have 1 nitrogen and 1 nitrogen atom. The atomic number for both is 7. Configuration is 2, 5. Both of them need 3 electrons to attain stability. So this is how we are going to show 1 nitrogen. Got it? So 5 electrons, we are going to arrange these valence electrons surrounding the nitrogen atom. So this is how we are going to show 3 electrons in the center and the rest 2 electrons on this side. Likewise, we can show for this nitrogen. So this nitrogen possesses 5 electrons. Got it? 3 it is sharing with the other nitrogen atom, and somehow it has attained stability due to mutual sharing. In a similar manner, this nitrogen atom possesses 5 electrons. It will also share the 3 electrons of other nitrogen, and triple covalent bond is formed, and both the nitrogen atoms now attain stability. That is the noble gas configuration. And how it has attained? Due to mutual sharing of electrons, or you can say due to the formation of covalent bond. Got it? So this is how we have to form ionic compounds and the covalent compounds, and this is how you're going to show the ionic bonding and the covalent bond. Now what you need to do is take few other ionic compounds and the covalent compounds, or you can say metal and a non-metal, and try to form bond between them. Once you'll start picking your own elements and you start forming showing bonds, you will come to know that how these kind of bond formation take place, and even you can attempt any question then, right? So please practice it. Go through your chemistry books, pick some compounds and just start forming the ionic compound and the covalent compounds, or you can say the ionic bond and the covalent bond, just taking into consideration their valencies, their atomic numbers, their electronic configuration. And also please consider that whether they are metal or a non-metal, or you're forming a bond between two non-metals, because accordingly you have to form ionic or covalent bond.